So good morning, all of you.
Good morning, sir.
So today I thought of discussing with you regarding this space complexity. Uh, I will also discuss stack programming today. So I first discuss space complexity today in this few first hour, maybe or maybe at 10 o'clock. I'll just look into that. Yeah, just have a recap of your exercises. I have just uploaded a new exercise. Just look into that exercise once. And if you have any doubts, you can see. I will start explaining about space complexity from 10 o'clock. So after space complexity, in the next periods, we will discuss about stack programming. And so this is our plan today. So first of all, I have uploaded a small exercise on linked list, which is the name with switches. Okay, switches linked list exercise. Just look into the description of that exercise and please try to understand what it is. And if you have any doubt, just ask me now. And if it is not so, you can start doing it up to 10 o'clock. And from 10, we will start discussing it. Yeah, I'm just repeating it once again. You just look into the exercise switches exercise that I have uploaded in my website. That means your learn.geetham.edu, and just try to understand this one. And if you have any doubts, you can just ask me now.
Excuse me, sir.
So how many of you have tried this program? What's your progress? I haven't seen any progress yet.
It's 10 o'clock.
So no progress. Is there any doubt in this particular one? Have you understood the exercise, what I have given, or any doubt in that? Say either yes or no, because with no answer I cannot.
So can you just explain it once, please?
Ah, okay, then you would have asked me before itself, right?
Sir, I called you, but you didn't respond actually.
No, I did not hear anything.
Okay, sir.
Okay. So where haven't you understood? Can you just tell me?
Sir, is the input a string or a linked list? Because when I'm looking at the test cases, it is the same as the previous test cases. So it is giving the
Yeah,
node only as input.
it's a linked list. The input is a linked list. But to make you understand that, I am giving it like a string, but it's a linked list. And you have to return the list of the number of switches that are on. So based on the line number 3 to line number 7, you can understand that there is a switchboard which is having 8 switches. Each switch has a number like 0 for switch 1, 1 for switch 2, and 2 for switch 3, and so on. So by this, you should be understanding that 8 switches are there and each switch starts from 0. So maybe I have something like it is looking like a byte with 8 bits. Okay, let me read further. So the switch numbers will be 0, 1, 2, 3, 4, 5, 6, 7. So it starts at 0 and ends at 7. If the switch is on or off, then an integer number with 2 to the power of the switch number is recorded as linked list. So that means by this time you might have understood it is completely working like byte with 8 bits. So it is like 2 to the power 0 to 2 to the power 7. So from 3 to 7, what I am telling is I have 8 switches and each switch has a number 0 to 7. Okay. So switch number 1 will have 0th number, switch number 2 will have 1 number, switch number 3 will have 2 number, and so on. And if a switch is on, it is actually recorded as a linked list with its 2 power. So if the switch number 0 is on, so 2 power 0 is entered into the linked list. So all your nodes are the numbers which are the answers of 2 power that switch number. So it is all like your bytes, simple thing, right? So I have a story for this. Ram, a student, is now tasked to switch on and off the switches. For every turn, Ram can on and off all or few switches any number of times. Okay. So the data for on and off of the switches will be recorded as a string and later converted as a linked list. Of course, as part of the story, whatever he tries to do is actually recorded as a string and later converted into linked list. So this string and linked list is given by me anyway. So I have converted a string into a linked list and the linked list is passed to you. So in the 15th line, I have clearly said, your task is to find which switches are on at the end of the turn. Okay. So sometimes, so for example, there is a single turn. So each linked list is a single turn. So some time will be given to him. Okay. So for example, 5 minutes of time. So what he says is that he switched on 0th switch. He switched on the number 2 switch. Again he switched off the 0th switch. Again this time he switched on the 7th switch. This time he switched off the second switch. And finally, how many switches are on? Can you tell me based on my example? Just now I have said one example, right? I don't think everybody is attentive to hear to me what I am saying. Finally, how many switches are on with this example which I told you now? No. See, I told you the
They
story.
all were turned on, but after they were turned off.
No. Finally, 7 is remaining still. So what I told you clearly, if he has first, I have given 5 minutes of time to him. Each term is some time. So he switched on 0th switch. Next, he switched on the second switch, the second number switch, and he switched off the 0th switch, and he switched on the 7 number switch, and he switched off the second number switch. So finally, how many switches are on?
One switch.
Only one. That is the switch number 7. That's what the entire program is about. So I give you a linked list. For example, 2, 4, 32. You have to determine which switches are on. So 2 is nothing but 2 power 1, right? So the answer is like this. 1 is given in this. Okay. And 4 in the linked list is something like the switch number 2 because 2 power 2 is 4. So switch number 2 is on. 2 power 5 is, so switch number 5 is on. So based on the linked list, you have to return a list of all the switch numbers which are on at the end of a term. So the linked list is something like I assume that Ram is present somewhere else and he is given some 5 minutes of time to switch on and off some things, and all those things are recorded as a linked list finally. That linked list I am passing it to you, and you have to determine finally which switches are on based on whatever the linked list has recorded. This is like not your, what we say, your household switches. So have you seen our in science fiction movies and Star Wars or something? The switches are different, right? Sometimes you press, first time you press it will be on, again you press it will be off. It's like a button, a simple button. Okay, so the button actually works like that. So on and off type of things, buttons will be there. It will work for on and off in the same way, not your household type of things. Like you have a switch where for off you press it on the upside, and for on you press it on the downside. Not like that. There will be a round button where you just press it. For every press, it will record either 0 or 1. That's all. So if it is at 1 now, it will record at 0. Again, if you press, it will record 1. Like that type of switchboard it is. So you should be thinking about that one also. So you see here, in this case, in the line number 38, it is 2, 4, 2. Now, can you tell me how many switches are on by the end of this term?
One switch.
One switch. That is 2 power 2. Because first he switched on 2, next he switched on 4. That means 2 means it is one switch and 4 means it is second switch, right? That means 2 switch. Because 2 power 2 is 4 and 2 power 1 is 2. Again he pressed on the 2 switch. That means again he switched off the switch number 1. So finally you will have only one switch on. That means 2. That only should be returned as a linked list. And so I have even clearly given you that you have to sort the entire linked list and give it to me. So for example, see the test cases. Every time it is in an ascending order, whatever the order might be. I might give, see, something like this. In line number 33, you can see 2, 4, 32, 16, 4, 2, 4, something I will give. But you have to arrange them in an ascending. Finally, the switches that are on should be in an ascending order in a list. So it's very easy. Like, you bring out the list and finally sort it and return it. That's all. So your return part should be list and your input will be linked list. Okay, I hope you understand now. Any doubts still?
No, sir.
Yes or no? No? Right. You can do this one. It's quite interesting and good logic can help you a lot. So this is what long back I have designed for one part of workshop. So I'm just trying to give it to you. Okay, let us come to complexity. Yes. Now, in the previous session, we have discussed about time complexity. Now, can anybody tell me what do you expect from space complexity? Any answer from you?
So writing a program which takes as much less space as possible.
Writing a program as much less space as possible. Okay, is some answer. So you have told me something like so you should not occupy more number of space. Okay, fine. Any other answer? Any answer? Okay. So time complexity and space complexity are very important concepts in data structures. I will tell you the reason why they are very important. When you are a good programmer, so for example, you might be working in Google, Facebook, or Twitter or something. There, Microsoft, Apple. So these companies are striving for efficiency because they are product oriented companies. They launch their own product. They don't work for service orientation. Even for service orientation also, if the product company is giving some consultancy. So Microsoft doesn't do everything on its own. It will design few things and give it to some sub companies in India. They're called attached companies. So some consultancy companies like that. There are also software companies like the Sonata and different companies are there where they will work with Microsoft by going to USA on site or off site something. What these people will do, they have to work few modules given by Microsoft and they have to submit them. Product orientation always demands some efficiency. How does this efficiency come? So based on the environment they deploy the software. The deployment is very important in software engineering because after requirements collection, you collect the requirements, what the market is thinking, and you design something. Without design, you cannot do, right? Before you buy an apartment, everybody will give you some design of the apartment, right? So in software engineering, design also is a very good part. Using UML diagrams or your flowchart, using the Raptor type of tools, they will design everything for the software. After that, you coders will do coding. So when you go to the company, you don't think about all these things. You will be given some module and you will be asked to finish that one. That's all. You're part of a project. There might be number of teams or only your team will do the project. So it's your task to only just code it. Design will be done some by team leaders or project manager or something. The project manager sees the overall estimation. He develops the cost estimation, the persons, how many people are required for the project and how many days the project should go on is all designed by the project manager. What the team leader will do, individual tasks will be given to the team leaders. Individual tasks will be given to the team leaders and team leaders will start analyzing the design and divide the modules of code to you individuals. So that is the reason if you are a software engineer, you don't know completely about the project because it comes to the from the higher level to the lower level. So slowly the people will understand how to code, and after you code, this all code will be sent to the testers, and the testers start testing it. And after testing it, the people think about deployment. That's the reason why you say the alpha, beta tests and all. So beta version, alpha versions type of versions will be launched with the operating system, right? This deployment, they will test it in two parts. One is in the workspace itself where they have developed the software, and the other is in the a user end environment. So for example, I am using in my home. So they will give me a beta version and ask me to test it. So remember, when you start a deployment, you also need to think about the end user hardware, how it runs, and what is the type of thing that you need to use. If you're using more memory and you think the minimum user using as an end user is having a laptop with minimal space, then he never buys your software because your software will always hang because the memory is not sufficient and your program is taking a lot of memory. He will discard your software. He will never come back to you buy your software. So based on the minimal user who is using the minimal configuration at the end part, the softwares are kept with some restrictions. So they will clearly give you the restriction that you have to design an algorithm either with time complexity or space complexity. Most probably, sometimes if you need to save time complexity, you also have to discard space complexity, or sometimes if you want space complexity, you have to discard time complexity, or sometimes you need to have both. Without these restrictions, people cannot even give you a contract of doing a software. So space complexity is not about just occupying some space, more number of space. It's not the basic concept of occupying more number of space. It is about discussing the input relation with the output. So whatever the input you give and the space that is occupied based on the input, then your algorithm is very, very bad. Very, very bad. But sometimes we cannot escape that bad. We cannot go to good sometimes. For example, if I have given you something like what we say n number of input, and you want n number of spaces for storing the input, then your space complexity is designed as big O of n. So it is different from the time complexity. Time complexity depends on the processing power of input, given input. So how many constant times it is executing based on the given input using for or while loops or if conditions or something. But space complexity is how much space it occupies based on the input. Now, the space is divided into two parts. One is auxiliary space. The other one is direct space itself. I will tell you what is an auxiliary space. Now see this one which I have given you. An auxiliary space is some space which is temporary or an extra space. Have you remembered in our insertion sort, selection sort, and bubble sort, we have a variable called temp, we have a variable called selection, we have a variable called minimum something, right? Have you remembered this one? Can you say yes or no?
Yes, sir.
Yes. That's called an auxiliary space. Generally, auxiliary spaces are one or two spaces or n number of spaces which doesn't depend on the input. If you have given 100 variable, 100 elements in your list to sort, the auxiliary space temp will be only one. If you give even 1000 elements to sort, still the auxiliary space will be only one element. Because you are, when you are comparing in your insertion sort between two things, you will have every time some number in the selection, right? Or your temporary variable or your minimum in the bubble sort. It doesn't depend on the number of elements that are there in the list. Whether you give 100 or 1000 or 1 lakh, it's not at all dependent on this input. So most of the time, when you talk about insertion sort, bubble sort, and selection sort, you don't need any extra space except only one thing like your temp or your selection or your minimum element or something. And hence the space complexity of your bubble or insertion sort is always considered as big O of 1. Only big O of 1. Because you will only have one extra space, that's all. You are not spending more space for that. Anyway, you are getting an input as a list, right? To store list, of course, the input should be stored. That's not considered as your space. The space is not about storing the input, but the space is something like anyway you get the input, and if you consider some other extra thing for that input is what the space that you occupy. So for example, when you buy a chair, naturally when you buy a chair, you are buying it because you have some space in your home and the space is allocated to you. It is not calculated at all. But when you buy one chair and it occupies two spaces, because to accommodate the chair, not only the space for accommodation, and there is something else also needed for this, then it is occupying some space complexity. Example, I will tell you, you buy a small fiber chair and you put it somewhere at the corner. You buy it because the space is already allocated to it. Yes, I'm hoping that you are understanding that one. You are buying a
Yes, sir.
chair, you are buying because you know that a space should be allocated to it. It is not a space complexity. But for example, if you have an electronic chair or something, so what does it mean? That your space is entirely dependent on your chair actually. So for example, you have an electrical recliner. So you need to accommodate the adapter, you need to accommodate the plug, you need to accommodate a space where the plug point is available. This is a little bit of headache, right? This is called space complexity. So input anyway needs a space that is never calculated. Based on input, if you want any other extra space, that is calculated. But that extra space is only one or two variables and it is every time temporary. It's called auxiliary space. But remember, the space complexity is a combination on the space plus auxiliary space. Always remember, auxiliary space is either extra small space or temporary space. The space complexity is a combination of both space and auxiliary space. And it is parallel to time complexity sometimes. So now I will tell you some example where you will find it out. There is a small example. This is a med sort. See how I have divided. I have given a list and the complete list is divided into two parts. 6, 1, 2, 3, 4, 5, 199. And again they are divided into 6, 1, 2, 3, 4, 5, 199. And again 6, 1, 2, 3, 4, 5, 199. And you see, this is the input that is given. And anyway, you need a space for input. It is not calculated. But dividing it into half and storing it into separate memories, how many memories finally you got? Can you tell me? For example, I will talk about there are n number of elements and you have occupied n spaces. And finally, after dividing, how many spaces you have occupied? Can you tell me? Okay, I got an answer in the chat. N, that's correct. Srinidhi. See, anyway, you need to discuss this as this one. For example, this is input. This is input list. And its length is n. The reason is it occupies n number. But we are not actually keeping the elements there itself and we are trying to sort it. See, we are dividing it into many parts. And finally, we are coming up to it comes to the single part. See why I have written T here. These are all temporary variables. These are all temporary variables. If there is one temporary variable, we can simply call it as an auxiliary space. But see how many temporary variables are needed. 6 is kept into temporary, 1 is kept into temporary, 2 is kept into temporary, 3 is kept into temporary. How many temp variables are required for this algorithm based on this? Can anybody tell me?
N, sir.
N. N number of temp variables are required. So MEDSORT time complexity is little bit better than insertion, selection, and quicksort, but see the space complexity. For insertion, selection, and bubble sort, you have only one temporary variable. Either you keep with some other name, but still we have only one temporary variable. minimum or selection or temporary something. It doesn't depend on the end input. It is not depending on the input values. It is only depending on itself. So it is always big O of 1. But see here, in med sort, you have n temporary variables. That means your complexity of your space complexity of med sort is big O of n. It should be n. So it is not one variable, it is dependent on the n number of input, and hence n number of temporary variables are created and they are stored there, and hence it is going to n. And you can also see those many times we try to divide it, the height also. There are n number of times you are trying to give the space. If you consider levels or if you consider elements also, those many spaces are required, and hence it is big O of n. Right. Now I will explain with a simple example. Just a second. Give me one moment. Yeah. Sorry for the disturbance. A small work. Okay. Right. Now let me discuss with you this one. Right. I want to write a program for the factorial of a number. So factorial of a number. So for this, I have two ways to do, right? For and using recursion. I hope you remember using for loop and also recursion. For example, I have given a factorial number is equal to 5. I want to find the factorial of a number 5. Maybe let us go with 6. So some more things will be there. 6. So I will give something like maybe fact number. Fact number. I will take it as 1. So can anybody tell me how do you write the for loop? For I in range. Can you tell me how much of range that you go?
6 to 1. So
Oh, you go, okay, 6 to 1 maybe. 6, how do you do 6 here?
Number, like
Oh,
1 to number.
yes, number, comma. So up to 0, will you go right?
Yes, sir.
Because you will go up to 1. And you are actually going to -1.
Minus
So
1, yes, sir.
yes, so you have to go with -1 as this one because you are going for reverse. So -1. Hmm. What is the next statement that you do?
Fact num is equal to fact num into number.
Okay, fact num is equal to fact num into I, right? Because I is starting with 6. 6 into 1 will be 6, and I is reduced to 5, and 6 into 5 will be 30, and I is reduced to 4. 30 into 4 is 120, and like that. Okay, it will go on. And finally, you will print the fact num. Finally, you print the fact num. Now let us see how it works. Let us go down to this one. Let me write the same code here and test what happens here. Just we'll wait for a moment, let it come. Otherwise I can, okay, I think it came. Okay, right. So as you told that, I will give the number is equal to 6. Fact num is equal to 1. Sorry. For I in range number comma 0 comma minus 1, because it's reverse. If it's not reverse, you can just give 0 comma number or something up to that number. But it should be 1 comma number plus 1 every time. Now you have fact num is equal to fact num into I. Sorry, into I. Right. The next one will be print fact num. And can you tell me what is that extra space that you had and what is that space by default required? Can you analyze the program and tell me what is that extra space that you had, either temporary or extra space, which doesn't depend on the input? And what is that space anyway that you require that is not calculated into space complexity, which is calculated? Do you
So maybe
calculate?
fact num is
Yes,
temporary.
yes. Your answer is correct. You only calculate the fact num. The reason is because the line number 1 is an input, right? The line number 1 is an input. So that you are getting as an input and it's required. Why do you calculate into space complexity? It is required. So based on the number that you get and to do the program from line number 2 to 7, how many extra variables that you are taking to finish up your job? The extra variables are only fact num. Now let us see. Execute this program and see this one. And you carefully observe this and tell me what should be the complexity of bar. Right. Okay, in a global frame you have a number 6 and fact number 1, it is initiated. Okay, so you see clearly I is increased. Oh, he's desperate to advertise something. He wants money, I think. Okay, I is increased, and next you see carefully. See, the fact number is still there and all the values are changing in the fact number there itself, right? So next 120, whether I or fact number, basically we focus on the fact number, which is very important for us. And finally you have 720 and finished. And can you tell me based on this, what is the space complexity of this program?
O of 1, sir.
Yes, that's correct. Big O of 1. The reason is we are only using one variable. We are not creating n number of variables of fact num, and in that one variable itself we are changing all the values. See how minute we are analyzing the space. So this is just called auxiliary space, and you can simply say it is big O of 1, like your insertion sort or selection sort or bubble sort. So you need to understand which variables are very important. Even if you take I also as important, it is also big O of 1, because every space is only considered one time. It is not dependent on the input, because you have given the number 6, the fact num and I are not declared for 6 times. It is only declared for one time and its memory is changing, that's all. We have only one time declaration. No parallel declarations of fact num like this. So we have only one time existence. Now you will understand if I come to the next code. I will write in parallel with this. Now I want recursion. How do you use recursion now? So maybe I will give the same. Number is equal to 6. And I want answer is equal to fact of number. I'm sending the number here and print answer. So I will write a definition fact of fact num. So I'm receiving it as fact num, right? I'm using the same type of variable. Now tell me, what is the code that you can do for recursion? What is the first condition that you keep? Because you are receiving 6 and you should stop at 1, right? So what is the condition? You should not go beyond 1, because if it is multiplied by 0, it will be all 0. No factorial will appear to you.
If fact num equal to 1.
Yes, if fact num equal to 1, then you simply say return fact num. That is the last number that you return. Else what you do? Return what? To calculate the factorial, what you want to do?
Fact into fact num into.
Fact num into fact of
Fact
fact
minus
Fact minus 1.
minus 1. So this is what you have done, right? Because every time the fact num is 6 into fact of 5. Next, in that 5 again you will have 5 into fact of 4, and slowly one by one returns to that, to the previous. This recursion I have explained you with an example in the previous videos, right? If you have any doubt, you can just view that video and get back your recursion thought again, because recursion is important in trees and you should be ready with a recursion as an equipment with you, right? Now let us execute this one. Let me see, come to the last. Yes, the answer is correct and it's printing 720. Now let us come to the first and execute each one. So we have number. You can see the fact object, that is the function, is created. And you see there is a function called fact, right? And in that you have a variable called fact number with 6. Now we'll see, let us see. So it is the line number 4 will be skipped and it will come to else, and it says return fact number into fact of fact number minus 1. Yes, again we are calling factorial, right? And again we have fact number 5 this time. Again. Now, this fact is calling this fact is calling this fact. You can see clearly. But this is not deleted yet. Its fact number variable is still alive until your final answer comes. And this fact number variable is still alive. And this fact number variable is also still alive. Let us see. And hence, you need to understand that now based on this, can you tell me what is the space complexity of this program?
big O of n, sir.
N, big O of n. The reason is earlier using for loop, you have only fact num declared one time. But you know, you are talking about space complexity of an entire program. So how much of space it is occupying? So you see the recursion, the function is calling itself, and how many times it is calling, it is dependent on the number. If the number is 6, the function is calling itself for 6 times. And every time it is declaring the fact num, it is repeating the fact num for 6 times. And hence your fact num is dependent on the input. And if the input is n number, it is declared for n number of times. It is not like your for loop. Even the number is 6, the fact num is only the single variable, and it is not creating any extra memory. You can observe this one. See, you have only one fact number, and every time the number is changing there itself, you can observe that, right? But here the number is still constant until it returns some value. And there are fact nums declared for n number of times based on the number n. So this is called big O of n complexity. So this is where the space complexity comes into existence. It's not auxiliary space. It is a combination of both auxiliary and space. Why I'm calling both auxiliary? Because fact num is an extra or a temporary space, which is auxiliary space. Along with this auxiliary space, it is occupying this much of memory for your program, this much of space. And this is where you need to calculate the space complexity. And this is where you will have the space complexity as big O of n, because it is dependent on the n input. And I will give you some more example that you already have done it, and you tell me how you have finished up with it. So earlier I have given an exercise, right? You have linked list like this. I have given a linked list, and I have given some numbers like 5, 20, 1, 100, and I told you to sort them. So I think 1 or 2% in the other section or this section, I don't know, but most of you have done with using the hint I have given you, like converting these nodes into a list, right? 5, 20, 100, and sorting it. After sorting it, your list is sorted like list.sort 1, 5, 20, 100. And again, you started to convert them into a linked list. This is what you have done, right? Yes or no?
Yes,
Yes.
sir.
Yes. So you will have 1, 5, 20, and 100. And now you tell me, what is your big O space complexity?
N, sir.
N. The reason is, if there are n nodes in the input linked list, anyway, you need space for the linked list to be accommodated. But along with that, to process this linked list to sorting, you have n list declared. Right. Anyway, sorting is equal, so not a problem. So combined to this, you have n list declared. So your list is dependent on the n number of nodes. So for example, sometimes you might have, based on n number of nodes, sometimes you might be having n square also. N square list also required sometimes. We don't know. Based on that, you will say the big O of n square or something. But in this case, you have n list declared. After sorting it, again, you are creating into a linked list. Anyway, this is the space that is considered as extra auxiliary space. But this auxiliary space is dependent on the n input, and hence this should be calculated for space complexity. I hope you are understanding now. Now, I have a program like this in binarysearch.io or .com. What they have said is, when I have done initially like this, I did not see the constraint that they clearly asked me for space complexity. I have written the program like this. And they have said that your program will be deleted because it is not at all adhering to the rules. It is not following the space complexity. Then I tried it again long back. So I remember the program. That is the reason I have given you this exercise. You will know now. So what they said is, you should do this program in big O of 1 complexity, not dependent on the n number of nodes. So if I create a list, they are saying it is not adhering to space complexity of big O of 1. They deleted my program. I was insulted. So I started to do it again. Without using list, I started to use some temporary variables, maybe 1 or 2 or 3 temporary variables for me, where I will keep hold of this. For example, this is root, this is temp1, this is temp2, or left hand, my right hand, or something. And I started to sort it there itself using either insertion sort or bubble sort or selection sort. Same, how you have done with the list, I have done with the nodes. So I have used it as a left hand and right hand, and I will have a border. So I only have 3 temporary elements. They are not dependent on n number. If you have the linked list of 1000 nodes or linked list of 1 lakh nodes, it is not dependent. Every time I will have a border, temp1 or left hand 2, and another. Maybe if I'm using selection sort, I will have selection or temp or minimum, whatever it might be. I have only 4 temporary variables which are not dependent on n number of input. I hope you are understanding. So what I will store in these, I will store the addresses of the nodes whenever I require. Like you have stored your indexes in the list, right? I will store the addresses of each node whenever required. And by this, I will come with big O of 1 complexity. I have a message. Sir, we use recursion method to, so Srinidhi says, we use recursion method to decrease the number of code lines as the user would not like large code. But using recursion increase the space used. Between time taken to complete the program and the space used, what should be given more importance? Yes. Yes, Srinidhi, that all depends on the client demanding you. For example, he has large amount of space. So space complexity is not dependent on the number of lines of instructions. Now I will come to this part. So when project manager estimates the cost for your project in software industry, he will demand the team leaders to reduce the number of lines of instruction and write the code, because the number of lines of code will generate a cost estimation such that these many software engineers should be recruited, and this much of salary should be given, and this much of hours the people has to spend. This is what the project manager will calculate, and project manager will demand you to reduce the code. If he definitely reduces the code, if he wants to you to reduce the code, sometimes you have to sacrifice your space complexity. But if the project manager demands you that, okay, whatever lines of code is not important, but the space complexity is important because our client asks for that, because at the end user side, there is no much space. Then you can write very big program, and you can go for space complexity. Sometimes people will demand time complexity. I have less processing power, and hence my program should work with less complexity. For example, the programs that you write for rockets, how much of space they will give it in a small rocket, right? Small chips, and with small memory it will go. So it should not occupy more and more space. So there are scenarios where you should give importance to few things. Based on the demand, you have to write the program. So as I said, for this program, I have two things to be done. I can write the same program in big O of n complexity. I can write the same program in big O of 1 complexity, as I have told you now. So based on the demand, I can choose any of this. If they said space complexity is important, I will go for that. If they said space complexity is not important, you can write any program. I can go for this because it's easy for me to do. Because you see, just I can use one sort, list.sort, it will sort everything. Just I need to convert it into a linked list and sort it. But you see, here I have to do it everything manually. I have to select my insertion sort. I have to select my bubble sort, whichever sort I want, declare my own temporary variables and sort it. So this might increase some time for me to do and write large code. But writing large code is not important, and space complexity is important. You can forget about large code. You can write it and depend on your space complexity. So why I'm telling this is big O of 1, you can say every variable I have declared, the temporary 1, temporary 2, or left hand or right hand, the border, and the selection. I just give only 4 temporary extra variables, which are not dependent on the input, and they are only declared one time, and hence it is big O of 1 complexity. I can go for that. And you can go for this, like if you have n number of nodes, I'm giving n number of list, and hence I'm declaring extra space of n number, and hence I should go for big O of n. So I think, Srinidhi, I have clarified your doubt.
Yes, sir.
Okay, right. This is all about your space complexity. I have told you 2 examples, which is one done by you practically both. So you have done the factorial using recursion and for loop also. For list, you have done big O of n complexity, and now I challenge you to do it with big O of 1 complexity without using any list. You can directly go and sort the linked list. I see one of your classmate or the other section classmate has done it without using list, and he has even gave me the code also. Sir, I have done it like this. So he has sent me in a WhatsApp. I have seen that code. It's very perfect. I don't know who is that. Which section, I don't know. Right. So I think with this, we can close this session for today. It's already 10:50. You can take some 10 minutes of rest and go to the next session. We'll meet in the next class. Bye-bye.